Okay, in this video we're looking at negative indices. So we're just going to evaluate these terms and see if we can find a pattern. So 3 cubed we know is 27. You can do these on your calculator if you want, especially when you get to the negative ones, but you'll notice something. 3 squared is 9. 3 to the power of 1 is 3. We know from previous videos anything to the power of 0 is 1. Just notice as we're coming along is that we're dividing by 3. As we go down 1 power less of 3, we're dividing by 3. So if you actually go to your calculator and do 3 to the power of negative 1, change it so that you get a fraction, you'll find that you get a third. But also continuing with this pattern, divide by 3, divide by 3, divide by 3. 1 divided by 3 is a third. If we do 3 to the power of negative 2 on our calculator, we get 1/9, but just notice that 1/9 is 1 over 3 squared. And so we've also divided that by 3, and on your calculator, 3 to the power of negative 3, if you do that, you'll get 1 over 27, but writing that as powers of 3, we get 1 over 3 cubed. Now I'm just hoping that you can see that clearly. So therefore, if we look at this, 3 to the power of negative 1 is 1 over 3, or 1 over 3 to the power of 1. 3 to the power of negative 2 is 1 over 3 to the power of 2. 3 to the power of negative 3 is 1 over 3 cubed. So now just replacing that 3 with any pronumeral a, we would get a to the power of negative 1 is 1 over a to the power of negative 2 is 1 over a squared, a to the power of negative 3 is 1 over a cubed, etc. So therefore, in general, we can say that a, or where a represents, it could be just a pronumeral, or we could have a number there. A to the power of negative n is 1 over a to the power of n. Okay, now let's have a look over here. We'll just do some examples now. So if you see a negative power, the negative you can think of as being 1 over. Okay, so express the following in simplest form without negative indices or grouping symbols. So 4 to the power of negative 3, the negative is 1 over, and then just write down what you've got left, which is 4 cubed. We know that 4 cubed is 64. B to the power of negative 5, the negative is 1 over, write down what's left. B to the power of 5 can't be simplified. Here, all of this, so all of the 3x is to the power of negative 4. Now the negative is 1 over. Then we write down what we've got, 3x to the power of 4. Now that means that each of these terms in here are both to the power of 4. So it's 1 over, it's 3 to the power of 4 times x to the power of 4, because there's a multiplication symbol between that 3 and x. Now 3 to the power of 4 is 81, and x to the power of 4 is just x to the power of 4. So therefore that is equal to 1 over 81x to the power of 4. The next one, here we've got 2a squared, or 2 times a squared, times b to the power of negative 3. Now we know that b to the power of negative 3 is 1 over b cubed. Now, so we're multiplying this whole number, I suppose you could say, by this fraction. Now if you want, you can put, remember all whole numbers are over 1. So when multiplying fractions, we multiply the numerators and multiply the denominators. So therefore 2a squared times 1 is 2a squared, and 1 times b cubed is b cubed. Okay, if you could please try these ones over here, which are the same as those, just with different numbers. And when you're done, just restart the video and check your answers. Okay, the very first one, 3 to the power of negative 4 is 1 over, remember the negative is 1 over 3 to the power of 4. X to the power of negative 8 is 1 over x to the power of 8. This term here, to the power of negative 2, the negative is 1 over, then we just write down whatever we've got now to the positive power. And looking at each of those terms inside the grouping symbols, each of those terms must be raised to the power of 2. So that's 5 to the power of 2 times x4 to the power of 2 times, but I don't have to put the times symbol in, just putting the brackets means times anyway, times y cubed to the power of 2. Now don't get confused here, just remember what your index laws are. 5 to the power of 2 is 5 times 5, or 5 squared is 25. X to the power of 4, raised again to the power of 2, we do 4 times 2 is 8. and here y cubed to the power of 2. Remember, we do 3 times 2 is 6. Okay, now writing this here without negative indices. Now there's a really quick trick that I want to show you. So for example, if I've got x to the power of negative 2 up here, when I move it to the denominator, it will be x squared. And if I've got z to the power of negative 4 down here on the denominator, if I decide to move it up there, it will be just as positive z to the power of 4. Now, I could do this, if you want, I will do this question the long way, but I'm just going to show you here just the quick way. Let's keep all the positive powers where they are. And if we want to move the, notice here the b to the power of negative 3 is on the numerator, because you can think of this as over 1. And if you move this, it ends up down here on the denominator, but as a positive power. So I'm going to keep the 3 there. X to the power of negative 2, I'm going to bring it down to the denominator. So it's x squared on the denominator. Y cubed is positive, so I'll just positive power, I'll keep it up there. Now instead of leaving z to the power of negative 4 down here, I'm going to move it up here, but when I move it, it's z to the power of positive 4. Now that is the answer we're going to get, but I'm actually going to do this the long way and just show you that I will get that same answer just by using index laws. So we've got, this means 3 times, so I'm just going to do the numerator first, and so I've got 3 times, now x to the power of negative 2 is 1 over x squared times, this is y cubed. So all of this is going to be divided by z to the power of negative 4. Now I just want to keep that separate because that is my answer. So this will be 3. Now this is 3 over 1, this is y squared over 1, y cubed over 1. So multiplying the numerators, I've got 3 times 1 times y cubed is 3y cubed over x squared. Now divided by z to the power of negative 4, so that's divided by 1 over z to the power of 4. Now remember, when dividing by a fraction, you change the divide to a times and you flip the second fraction. So we've got 3y cubed over x squared times, change the divide to a times and flip the second one, times z4 over 1. Now if I multiply the numerators, I'll get 3y cubed times z to the power of 4, which is what I've got here. If I multiply the denominators, I've got x squared times 1, which is x squared. So girls, it's just much easier to move this x to the power of negative 2. To get rid of the negative power, just move it to the denominator and write it with a positive power. To get rid of this negative power, just move it to the numerator. And it'll be a positive power. It's like you're doing two opposites, okay? I mean, you can go through and do this method, but it's just much quicker to do this, okay? Now, you would normally not get asked to write this, to do this, all right? Normally, it's much better to have everything in positive, with positive indices. However, if I did ask you to write this with negative indices, if this is an x to the power of positive 4 on the denominator, if I move it up to the numerator, it'll be an x to the power of negative 4, okay? Same here, but as I said, you would normally not do this. I'm just showing you that when you move it, that, so at the moment the a cube's on the denominator, so if you want to move that a cubed to the numerator, it'll be a to the power of negative 3, okay? But, of course, there's no purpose in doing this. You normally wouldn't do it, okay? Here, the 3, because this is 3 times x cubed, so the 3 stays there. Leave the x cubed there at the moment, and I'm going to, actually going to evaluate this. This is 4 squared times y cubed squared. So before I go moving things from numerator to denominator, etc., I'm going to get rid of these brackets and take each term inside to the power of 2. So I've got 3x cubed over, now 4 to the power of 2 is 4 squared, which is 16, and this will be y to the power of 6 because we multiply the 3 and the 2. So if I wanted to write that now with negative indices, I'll keep my 3 and 16 where they are. Right, we're only writing the x's and the y's with negatives, but of course you would normally just leave the answer like that. You wouldn't go and write your answer normally with negatives. But just showing you, if I want to put the x cubed down the bottom, it'll be x to the negative 3. And if I want to put the y6 up the top, it'll be y to the negative 6. Okay? All right, now if you can just try that, writing them with negative indices, restart the video when you're ready. Don't move the number, just keep it there, but just writing the reason we don't, this 2 has no power, it's got no index anyway to be written with negative indices. So if we want to write that x squared on the denominator, it would be x to the power of -2, and if I wanted to write the y to the power of 5 on the numerator, or with a negative indice, I'd have to move it up to the numerator. Okay, now keep the numbers where they are because there are no indexes there. C to the power of 4 on the denominator becomes c to the power of -4 on the numerator. D cubed on the denominator becomes d to the power of -3 on the numerator. So now they're both on the numerator, so we basically don't have a denominator, and we can just write it like that. Now with the next one again, making sure that you take each of these to the power of 3 before you start. Okay? So I've got 1 over, now 3 cubed is 27, and x to the power of 5 cubed is x to the power of 15. If I want to write that with negative indices, the 27 stays at the bottom, and we've got the 1 up the top. I'm not going to put the 1 yet because I'm going to move this x to the -15. X to the positive power of positive 15 on the denominator is x to the power of -15 on the numerator. There's no need to put the 1 in front of there. Okay, we're going to look at the other side of this now. Before we go to the other side, I just want to add something here. See how we've got this rule that a to the power of -n is 1 over a to the n. I just want to do something else. 1 over a to the power of -n. So if I start with this, 1 over a to the power of -n, we know that that's the same as a to the power of n. Okay, so if it's an a to the power of -n on the denominator, it's an a to the power of positive n on the numerator. So you might want to add that rule in as well. Okay, we've been doing that, but I never formalised that rule yet. Okay, so for example, 1 over x to the power of -3 is just moving it to the top, it's x cubed. Okay. However, something like 1 over 2x to the power of -3, I don't want to move the 2. If I just move that x to the power of -3 to the numerator, it becomes x to the power of positive 3. I don't need the 1 in front of the x cubed, so I just write that as x cubed on 2. So please don't go moving the 2 up the top. That is a half. It doesn't then magically become a 2. Okay? Okay, now looking at a fraction, so a over b to the power of -1. We know now we're just coming up with this quick rule here, but we're going to do all the working out for it. So a over b to the power of -1, the negative power means 1 over, and then you write down what you've got, a over b, all to the power of 1. Now, because I've got 1 divided by a fraction, this is my main division line, because then I've got a fraction. I'm going to write this main division line as a division sign. So I go 1 divided by a over b. I don't need to put the power of 1 because a over b to the power of 1 is just a over b. Now remember, when dividing by fractions, we change the divide to a times, and then we write the reciprocal or the flip of the second fraction. So this becomes 1 times, divide goes to a times, and the a over b becomes a b over a. Again, noticing we've got 2 opposites. Okay, divide to a times, a over b becomes b over a. Now 1 times b over a is just b over a. Just looking here, notice that the a over b to the power of -1 has become b over a, and I suppose you could say you've got a positive 1 power there. Here we're doing it a over b to the power of -3. The negative means 1 over, then we write down whatever's left, a over b cubed. Now, remember, 1 divided by fraction, we don't want to see these 2 fraction lines, so the main division, or fraction, becomes a divide, so it's 1 divided by, all of this, a over b cubed. Now, we're dividing by a fraction, so we need to change the divide to a times and then flip, or find the reciprocal of the second fraction. So 1 divided by a over b cubed is 1 times b over a cubed. Now, here the a is cubed and the b is cubed, so we can just keep it in brackets, okay? And 1 times b over a cubed is just b over a cubed. Now, just look here, a over b to the power of -3. If the negative goes, the fraction flips, or you find the reciprocal of it. So therefore, the rule in general, again, 2 opposites, notice a -3, positive 3, a over b, b over a. It's like you've got 2 opposites that, I suppose, balance each other out. A over b to the power of -n, therefore, is b over a to the positive n. So now we're going to do some examples. So to write these fractions here without negative indices. So if I run from, so I've got 2 over 3 to the power of -1. If I want it to the power of +1, that's one opposite. The other one is going to be 3 over 2 to the power of 1. And simplify where possible, well, that would just be 3 over 2. 4 over 5 to the power of negative 3, that's 5 over 4 cubed. Reciprocal there and opposite there. So that would be 5 cubed over 4 cubed. We could, so each of those is cubed. To evaluate those, you get 125 over 64. And if you want, you can write that as a mixed numeral. Okay, the next one. Okay, now there are a few ways of doing this. I'm going to get rid of this negative first. So instead of being to the power of negative 4, I want it to the power of positive 4. So I need to just flip numerator and denominator. So make sure you've put all of this denominator up there and all of the numerator down there, okay? And you need to make sure you move them all. No, don't go changing signs or anything like that. I know before you were saying if you move it from there to there, we're just applying this rule first, that from negative 4 to positive 4, we then flip the fraction. Now we can do each of these to the power of 4. So I've got 2 to the power of 4 times n cubed to the power of 4 over 3 to the power of 4 times m squared to the power of 4. Now you can put multiplication symbols between these, but you don't need to. Now 2 to the power of 4 is 16, n cubed to the power of 4 is n, 3 times 4 is 12, 3 to the power of 4 is 81, and m squared to the power of 4 is m to the power of 8. Now don't think that there is any, you can't simplify here. Okay, you can always check on your calculator, 16 over 81, put it in as a fraction, and if it doesn't simplify, then you can just leave it. Okay, if you could please try this side over here and restart the video when you're ready. Now notice here, I do not have a clear numerator or denominator because I've got a mixed numeral, so I need to make an improper fraction here. Now 1 1/3 is the same as 3 times 1 is 3 plus 1 is 4 over 3. So this is 4 over 3 to the power of negative 1. So remembering that rule, if we want a positive power, we're going to flip this 4 over 3 to make it 3 over 4 to the power of positive 1. The second example, 2 over 3 to the power of negative 4. If we want a positive power, we need to flip this fraction. So that becomes 3 over 2 to the power of positive 4. Notice two opposites. Okay, here, let's get rid of this negative power first before we go working anything out. Now, I understand here that we've got a negative 2, but let's just use one rule at a time. The first rule is let's get rid of this negative. So I've got power of 3, so that means I put and just write them exactly as they are. The denominator goes up the top, the numerator goes down the bottom. All right, so we're just using that rule first. Now, we can do this a couple of ways. We can, if we want, just move this y to the power of negative 2 down the bottom, or we can start expanding if we want. Either way, it doesn't matter. So I might just move that y to the power of negative 2 down the bottom so that we're only dealing with positive powers. So see what I've done? I don't want to be dealing with a y to the power of negative 2 up here. I can just put it down the bottom on the denominator and it'll be just y squared. So now I can expand this bracket. So we've got 3 to the power of 3, or 3 cubed, over 5 to the power of 3. X to the power of 4 is cubed. So each of these must be to the power of 3. And y squared to the power of 3. And that gives me 27 over 125, x to the power of 12, y to the power of 6, remembering that we're multiplying the 4 and the 3 and the 2 and the 3. Now, if you decided you wanted to keep this y to the power of negative 2 up here, that would have just been y to the power of negative 6 on the numerator, and then I would have shifted it down to the denominator, and it would have been y to the power of positive 6. So you would still get the same answer. Now, in these questions here, there's nothing new. We're just applying the index laws, and remember the index laws are as follows. A to the power of m times a to the n is a to the m plus n. A to the power of m divided by a to the n is a to the m minus m. A to the power of 0 is 1. A to the power of m, then all of that to the power of n is a to the m times n. We've also got the negative indices. A to the power of negative n is 1 over a to the n, and that will do. Okay, so girls, what I'm going to do, we're just going to keep all these negatives we're going to just use these rules. I'm not going to go and put these down the bottom. I'm just going to show you how you can use your index laws without moving. Look, clearly I have no denominator here, okay, and I'm not going to go moving that down there at the moment. Let's just use our index laws, these ones. We've got 3 cubed, and then we've got y to the power of -2 cubed. So just using our index laws, 3 cubed is 27, and y to the power of -2 cubed, -2 times 3 is -6. Now, if you want, we know that y to the -6, so that's 27 times y to the -6, which is 27 times 1 over y to the 6, or 27 over y to the power of 6. Okay. The next one, just using our index laws. One sec. Question. Do the numbers first. 4 times 8 is 32. And we've got b to the power of -5 times b to the power of -3. Now that is like this rule here. Now if the bases are the same, you just add -5 plus -3. So we've got b to the -5 plus -3 is just, the plus minus can just become a -3. So we've got 32, b to the power of -5 and -3 is -8. So we've got 32, b to the power of -8. I just need a bit more room. And now writing that without negative indices, we get 32 over b to the power of 8. Okay? Sorry, I'm just hoping you can see that properly. Okay, the next one. I'm just going to use the index laws, but we could put this, we're just going to use the division index laws. So we've got, I can actually put it actually as a fraction, which might be better. 9x to the power of -4 over 3x cubed. That might actually be easier. What I'm going to do over here, I'm just going to do it, I can do this 2 ways, okay? If I'm just going to use index laws, I'll do that over here. 9 divided by 3 is 3, and x to the power of -4 divided by x to the power of 3, remember we subtract the indices, I've got -4 minus 3, I will get 3x to the power of -7, which is 3 over x to the power of 7. Or I can do it this way, using all the tricks that we've learned. So I'll just keep that on the side. The other way I can do this is writing this division with a divide sign. 9 over 3 is 3. Now, I can use the index laws if I want, but I don't have to. We can use what we've just been doing further up on the sheet or over the page. I can actually write this x to the power of 4 on the denominator as a positive power. So I can keep the x cubed down here, and I can keep it there because it's a positive power. So I've done 9 over 3 is 3. I can keep the x cubed there, and I can write this x to the power of -4 down the bottom as x to the power of +4 on the denominator. And so that will equal 3 over, now this is x cubed times x4, which is x to the power of 7. So that's another way of doing it. Now this 3x to the power of -7 is the same as 3 over x to the power of 7. The other thing you could have done here is 9 divided by 3 is 3. -4 minus 3 is -7, so you'd have an x to the -7 on the numerator, which would be like that, and then you'd move the x to the 7 to the denominator. So just a few ways of doing that. With this, I think we should just get rid of all the negatives, or we can do index laws if you want. I can do it both ways. So if we just want to get rid of all the negative powers first, so for example, I don't want this negative power here, I would write it on the numerator. Okay, here I've got b to the -4 on the numerator. Well, I don't want negative powers. I'll put that one on the denominator. And a to the power of -5 is on the denominator. Let me move that to the numerator. And this is what the question now becomes. So here is my numerator, and there. And this would be over 1. So I've got a2 times a5, sorry, is a7. And I've got b cubed over b to the power of 4. Remember, I can continue this. I would get a7b cubed on the numerator. I can just do it here. So that times that, and b to the power of 4 on the denominator. But now if I simplify that, I've got a to the power of 7 on the numerator. But remember, this is b times b times b, and this is b times b times b times b, and there's an extra 1b on the bottom. So 3 b's would cancel from the numerator and the denominator. I mean, the other way of doing it would be to purely use index laws. And that would be as follows. So I'd have, let me just multiply first. I've got a squared b to the power of -4 over b to the power of -3, a to the power of -5. Now, I particularly don't like doing it this way, but you can do it like that if you want. I just like to get rid of all the negative powers, and then I'm just dealing with positive powers. The other thing you could do actually over here while I'm talking about that, if you want to use index laws, you'd have b to the power of 3, and then you'd have to subtract the 4 and you'd get a b to the negative 1 on the numerator, which is a b on the denominator. So here, if you want to use index laws, just looking at the a's only, you'd get a2 take away, because when you're dividing, you're taking away, negative 5. That's what you'd have. And with the b's, you'd have b to the power of negative 4, because you're dividing by that. You go take away negative 3. So you can see using index laws can be a bit tricky doing questions like this. Now 2 take away negative 5 is 2 plus 5, which is 7. And I've got negative 4 take away negative 3, which is negative 4 plus 3. Now we know that negative 4 plus 3 is negative 1. And this would be a to the power of 7 over b to the power of 1, or just over b. So I think there's more room for error doing it this way, which is why I think you should get rid of your negative powers from the beginning. Okay, so have a go at these ones and I will restart the video. Or you can actually restart the video when you're ready. Okay, okay, looking at this. Let's just do each to the power of 3 first. We've got 4 cubed, a to the power of negative 3 cubed, b squared is also cubed. 4 cubed is 64. Then we've got a to the power of negative 9 and b to the power of 6. Now to write that with positive powers, the most simplest form is with positive powers. So this would be 64. I want to write that a to the power of positive 9 on the denominator. That's an a, that's a 9. And keep this b to the power of 6 on the numerator because that one's positive. Okay, now let's use the index laws for the next one. We can do that because it's times, it's probably easier. So 3 times 5 is 15. A squared times a to the power of negative 2, that will be 2 plus negative 2. A to the power of 2 plus negative 2. B to the power of negative 4 times b to the power of 3 would be b to the negative 4 power of negative 4 plus 3. So you get 15. Now 2 plus negative 2 is 2 minus 2, which is 0. So that's a to the power of 0, which is just 1. I'll just put the a to the 0. This would be b to the power of negative 4 plus 3. Negative 4 plus 3 is b to the negative 1. So this will be 15 over b, because a to the power of 0 is 1. B to the power of negative 1 is 1 over b. Okay? Now look, you can do this many different ways as well. I can put the negative powers down the bottom to start with and the a squared on the denominator as well. We might want to do that with this one here, but so I'm going to go that that's equal to 4. Let's just write the divide as a fraction line. So we've got 4a to the power of negative 3 b squared divided by 16 a cubed b to the negative 2 power of negative 2. Now I've just written them as they are, but just replace the division sign with a line, with a vinculum. So what I want to do here, let's just get rid of these negative powers. So just move this b to the negative 2 up and this one down. So 4, I'm going to keep this b squared here. Now this other one is going to move up there too. So just put it next to it. Over 16, the a cubed is positive power, it stays down there, but this other a to the negative 3 moves down and becomes a to the power of positive 3. So just see what we've got. B squared times b squared is b to the power of 4. And 4 over 16 is 1/4. So I've got b to the power of 4. Remember, 4 over 16 is 1/4. I'll put the 4 down there. A cubed times a cubed is a to the power of 6. So we've got b to the power of 4, 4a to the power of 6. Okay, with this next one. Okay, you probably want to get rid of your powers first. So let's take each of these to the power of 3. We've got 4 cubed, x squared to the power of 3, y to the power of negative 3 cubed over z to the power of negative 4 times, now we can do this one straight away, z to the power of negative 2 to the power of 5 is z to the power of negative 10 over, putting each of these to the power of 4, we've got 2 to the power of negative 4. X to the power of negative 2 is also to the power of 4, and we've got y to the power of 4 to the power of 4 again. So now expanding, 4 cubed is 64. X squared cubed is x to the power of 6. This would be negative 3 times 3, y to the negative 9 over z to the power of negative 4 times z to the power of negative 10 over, notice I'm not getting rid of negative powers yet, I just want to get rid of brackets and powers first. 2 to the power of 4 is 16. This would be x to the power of negative 8, because negative 2 times 4 is negative 8, and here I've got y to the power of 16. Now, the next thing to do, I'm sort of running out of room here. We can do this two ways. We can use index laws, or we can move powers, the negatives up and down, just to get rid of them all. So I'll just do that, but I'm sort of running out of room. I'll keep the 64. Let's just make this one fraction. So looking at numerator, I'll keep the 64, keep all the positive ones where they are. I've got x to the power of 6. I want to move these negative ones down. I want to move this negative one up. I want to move this x to the negative 8 up. So I'm going to move this x to the negative 8, becomes x to the positive 8. I'm going to move the z to the power of negative 4 up at z to the positive 4. So I've moved these negatives up. Let's move these negative powers down. Instead of y to the negative 9, it's y to the 9 down there. Z to the negative 10 on the numerator, z to the positive 10 on the denominator. I'm going to keep the y to the power of 16 on the denominator because it's a positive power already. And I've really run out of room. So, and I forgot to put this 16 here as well. I've got a 16 on the denominator. So 64 over 16 is 4 on the numerator. Now, x6 times x to the power of 8 is x to the power of 14. We've got z to the power of 4, z to the power of 10 on the denominator. There's more z's, so there'll be an excess of z's on the denominator. And on our denominator, I'm meant to be putting this over, but I can't fit it. So I've got 4x to the power of 14, all divided by 16 on the denominator. Y to the power of 9 times y to the power of 16 is y to the power of 25. And my last thing here will be z to the power of 10. Sorry, I think I'll just rewrite that. One sec. Sorry, and sorry about the noise. So from here I've got 64 x to the power of 6, x to the power of 8, times z to the power of 4 over 16 y to the power of 9, z to the power of 10, y to the power of 16. Sorry, just at school and then doing work outside. 4 over 16 is 4. X to the power of 6 times x to the power of 8 is x to the power of 14. We've got a z to the power of 4 over a z to the power of 10. Now you could write it as z to the power of negative 6 on the numerator, or just put a z to the power of positive 6 on the denominator. And on the denominator we've got y to the power of 9 times y to the power of 16, which is y to the power of 25. So I think you can see that. Sorry, and I did make a little mistake here. I wrote z to the power of 10 up here because I couldn't see that z to the power of 4. So that is z to the power of 6 on the denominator. Okay, finishing off this sheet that we were working on last lesson. We didn't manage to finish it, so I'm just going to finish that off now. So using index laws to do look at these expressions with negative indexes. Again, the bases are the same, so we're just adding 2 plus negative 2 is really 2 take away 2. Or 2 minus 2, which is 0, so that's 3 to the power of 0, which is 1. Again, the index laws, the rule when dividing is to subtract, so we've got the 2, take away negative 2, which is 2 plus 2, which is 4. So the bases are the same, we're subtracting the indexes here. Here the rule is multiply the indexes, so 2 times negative 2 is negative 4, 3 to the power of negative 4 is 1 over 3 to the power of 4. Now looking at these next ones, D, bases are all the same, but let's just do the division. Actually, we can do this all in one step if we want. So when you're dividing, you subtract. So I've got 2 take away negative 5. Now, whatever answer you're going to get there, because we're multiplying by negative 1, we'll be adding now, adding negative 1. So let's get rid of all these double signs next to each other. This will be 7 to the power of 2. Take away negative means plus 5. Plus negative means minus 1. So we've got 2 plus 5 is 7 minus 1, that's 6. So therefore this will be 7 to the power of 6. Okay, look, you can do it other ways. You could say that this is, the other way is 7 squared divided by 7 to the negative 5, and then we're going to times that by 7 to the negative 1. And you can move that 7 to the negative 5 to the numerator, so that's 7 squared times 7 to the power of 5. Now, instead of having 7 to the negative 1, that would be times 1 over 7. And we can see we've got 7 powers of 7 on the numerator and 1 power of 7 on the denominator, so you would get 7 to the power of 6 as well that way. All right, let's look at this one. Here I would do my brackets first. Here when multiplying, you add the indexes, so it would be 8 to the power of 5 plus negative 7. Whatever answer you get for that, that's all to the power of negative 4. Now 5 plus negative 7 is 5 minus 7, which is negative 2. 8 to the power of negative 2 to the power of negative 4. Remember, the rule is to multiply these. Negative 2 times negative 4 is positive 8. So that would be 8 to the power of 8. The other way you could have done it is to do each of these powers separately, and you would have got 8 to the power of negative 20 times 8 to the power of positive 28, and you would have still ended up with that same answer. So I can just do that over here in another colour if you want. So you'd get 8 to the 5 times negative 4 is negative 20 times 8 to the negative 7 times negative 4 is positive 28. And simplifying that, bases are the same. We're multiplying, so add the indices. Negative 20 plus 8 is 8. So that's another way you could have done that question. Okay, this one as well. Well, they're all base 10, so you would go 10 to the power of 2 plus 5. And if you want to do it in one step, you'd now just go take away 10, or we can do it in steps, okay? So you'd get 10 to the power of 7 over 10 to the power of 10, which is 1 over 10 to the power of 3. Now that's without using index laws. If I do, well, it sort of is just using them now, but if I want to purely use index laws, I would go like this: 10 to the power of 2 plus 5 minus 10 for the divide by this 10 here, which is 10 to the power of, now 7 minus 10 is negative 3, so that becomes 1 over 10 cubed, same answer. So there are different ways that you can do these. The next one, using index laws, this would be 5 to the power of 1, remember, and when we're dividing, we subtract, so we've got 1, take away negative 3, so it's 1, the divide is take away this power, negative 3, and here's divide again. So whatever answer you get there, you'd have to take away 6 as well. Okay, so we've got 5 to the power of 1 plus 3 is 4, 4 take away 6 is negative 2, so that would be 1 over 5 squared, or 1 over 25. It says to leave your answer in index form, so you can just leave it as 1 over 5 squared. I mean, the other way you can do this, I'd probably just do it that way. Otherwise, you've got to write, yeah, I'd probably just do that. You can see here that 1 take away negative 3 is 4, so it'd be 5 to the power of 4. If you want, you can just do the first two first. So you get 5 to the power of 1 take away negative 3 is 4, divided by 5 to the power of 5 to the power of positive 6. So I'm just doing the first two first, and then that's going to be 5 to the power of 4 minus 6, which again is 5 to the power of negative 2, so it's the same answer. So if you're worried about doing it all in one go, you can just do the first two first, get that answer, then divide by your 5 to the power of 6 next. With this one, I would probably do what's inside the brackets first, using those index laws. 11 to the power of 4, now this is multiplying, so we plus negative 5, and whatever answer you get there, well, it's going to be negative 1. We're then going to subtract, because we're now dividing, so subtract negative 3, and all of this has to be squared in a minute. So 11, now we've got 4 minus 5 is negative 1. Negative 1 take away negative 3 is negative 1 plus 3, which is positive 2. So it's 11 to the power of 2 squared, which is 11 to the power of 4. Now, if you're not comfortable doing that, you can raise each of these to the power of 2 first. So that's 11 to the power of 4 squared, which is 11 to the power of 8, times 11 to the power of negative 5 squared is 11 to the power of negative 10, over 11 to the power of negative 3 squared, well, negative 3 times 2 is, sorry, that should be 11. That's 11 to the power of negative 6. Now, I'm just working over there. And now you can, well, work on your numerator first. 8 plus negative 10 is negative 2 over 11 to the power of negative 6. Now, look, I wouldn't go using index laws here. I mean, you can go negative 2, take away negative 6 is positive 4. Or I'd say, well, they're negatives. And, I mean, we could have done this by putting them, the 11 to the negative 3 to the numerator, 11 to the power of negative 5 on the denominator, and made everything positive powers and just worked it out. But, you know, we're just practicing using negative indices with index laws. So here I could go, well, that's 11 to the power of -2 minus -6, which is 11 to the power of 4. Or I could have gone, put the 11 to the power of +6 on the numerator, 11 to the power of +2 on the denominator, and you would have got 11 to the power of 4. Now, with this one, you've got to do, I would write, got to be really careful with this. When there is mixed multiplication and division, you really sort of need to do it in order. And we are doing these in order because we're really getting an answer for this numerator, which would be 11 to the power of -1, and then we're dividing it by 11 to the -3. So here, but you just got to be really careful. So I think you should probably write these as positive powers. I'd probably do that because it's looking like it could be quite tricky. Or we can, yeah, I'll do that. So 1 over 4 cubed times 1 over 5 cubed. Now this is divided by 4 squared. So we have to do them in order, times 5 to the power of 7. So must be done in order. So we have to multiply these two first. So we get 1 over 4 cubed times 5 cubed. Then we're going divided by 16, or divided by 4 squared. Now I'm going to write that as a fraction. Divided by 4 squared over 1 means times 1 over 4 squared, and this will be times 5 over 7. And now that this is not a mixture of multiplication and division, and it's all just multiplication, I can just multiply all the way through. Now that's 5 to the power of 7, not 57. It looks a bit like 57. So I'm going to say that that's over 1. So on my numerators, I've got 5 to the power of 7. And on my denominator, I've got 4 cubed times 5 cubed times 4 squared. So now doing some cancelling, or you can use index laws. 5 to the power of 7 over 5 to the power of 3 will leave me 5 to the power of 4 on the numerator. And on the denominator, I've got 4 to the power of 5. Okay? All right. Now, look, we will be doing scientific notation later in the term, but we can have see that it's actually related to negative indices and positive indices. So it just says write each of these as a fraction or a whole number. 10 to the power of -1 is 1 over 10 to the power of 1, which is 1/10. 10 to the power of 4 is just 10 to the power of 4, or 10,000. 10 to the power of -4 is 1 over 10 to the power of 4, or 1 over 10,000. So you can sort of see the link between 10 to the power of 4 and 10 to the power of -4. Now, part 2. If you times something by 1/10, it's the same as dividing it by 10. For example, I might say to you, what's 1/10 of 20? You would say, well, that's 2. If I broke up 20 into 10 parts, I'd have 2 in each part. So multiplying something by 1/10 is the same as dividing it by 10. Multiplying something by 100th is the same as dividing it by 100. So it's saying here to write, each number below is written in scientific notation, and write each as a basic numeral. So this is 4 times 1/10. Now what we're using here, that's the same as 4. Timesing by 1/10 is the same as dividing by 10. That's the same as 4 divided by 10. Times 1/10 is the same as dividing by 10, which would be 0.4. This next one, 8.3 times 10 to the power of -4 is times 1 over 10 to the power of 4. Now, that's the same as saying 8.3 divided by 10 to the power of 4, or 8.3 divided by 10,000, which means moving the decimal place back 4 places. I think it's there. 1, 2. So when you divide by, remember when you're dividing by 10, you move the decimal place once. When you're dividing by 100, you move the decimal place back twice. If I'm dividing by 10,000, or 10 to the power of 4, the decimal place started there. I'm moving back 1, 2, 3, 4. Okay, this next one, 2.41 times 10 to the power of 7. That's 2.41 times 1 over 10 to the power of 7, which is 2.41 divided by 10 to the power of 7. And writing that, we're going to need a lot of zeros. We've got to move this back 7 places. So moving it back once puts the decimal point in front of the 2. So we're going to have another 6 zeros in front of the 2. So we've got 0.000000241. And this last one, 8.056 times 10 to the negative 9 is times 1 over 10 to the 9, or 8.056 divided by 10 to the power of 9. And we're going to have to move this decimal place back 9. So if we move it back 1, it's in front of the 8, so we're going to need another 8 in front there. 1, 2, 3, 4, 5, 6, 7, 8, and the rest of the number. Okay, so it was here. It's got to move back 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we're not going to worry about this last bit. Okay, now this last bit, it's saying is 2n to the power of negative 4 equivalent to 1 over 2n to the power of 4? Explain why or why not. Now we know that 2n to the power of 4 is the same as 2 times n to the power of 4, which is 2 times 1 over n to the power of 4. Now this is 2 over 1 times 1 over n to the power of 4. Because we're multiplying by a fraction, we need to make them both fractions. So therefore this is 2 over n to the power of 4. So therefore that obviously is not equal to 1 over 2n to the power of 4. Okay, so therefore 2n to the power of negative 4 does not equal 1 over 2n to the power of 4. It's because only the n is to the negative power, not the 2. Okay, so it says you can substitute. For example, let's just say if n is, say, 3. Let's check 2n. So that would be, looking at 2n to the power of 4, I would get 2 times 3 to the power of negative 4. And if you do that on a calculator, or you can just do it like this, 2 times 1 over 3 to the power of 4, which is 2 times 1 over 81, which is 2 over 81. Or you could look at 1 over 2n to the power of 4. If you sub n is 3, I get 1 over 2 times 3 to the power of 4. It's 1 over 2 times 81, which is 1 over 162. Sorry, didn't realise you can't see that. So again, 1 over 2n to the power of 4, replacing the n with a 3, we get 1 over 2 times 81, which is 1 over 162. Obviously, these answers aren't equal. Okay, and just seeing whether n to the power of negative 2 is equivalent to negative 2n, let's look. N to the power of negative 2 means 1 over n squared. And negative 2n means negative 2 times n. Now, these are clearly different. Let's just do a substitution. For example, if n is 3, we get that 1 over n squared is 1 over 3 squared, which is 1/9. And here, if n is 3, we get negative 2 times n would be negative 2 times 3, which is negative 6. Now, clearly, these two answers are very different. Okay, so that's the end of this video, and we'll be continuing in more examples in class, or some work in class from the exercise.